Hi class, today is 4.7, the population models, exponential, we're actually just doing exponential models today. A population in the world in 2000 was 6.08 billion people. We also know it's growing at 1.26% per year. Assuming the growth rate continues, the model is given here. Note that in this model here, that is your initial amount, which is 6.08 billion. And our growth rate is in here added to 1, the 0.0126. So you can do these two ways. You can use your graphing calculator, or you can use algebra. So I'm going to use the calculator for this one to show you how you can do that. We want to know at what time, or what year, and in how many years will the population be 9.17. So I'm going to say 9.17 is equal to this equation, 6.08 1.0126 to the t. So now that I have an equation in the calculator, you can say I want this in my y1 and this in my y2. So go to your calculators, which I have right here, and notice how I have plugged in these two things in my y1 and y2. You can pause the video to look at this if you need to. And now I'm going to go forward with that. When you graph it in Zoom 6, you notice that we can't really see where the intersection point is. We have to look more to the right. So I'm going to change my window. Right is x max. So I'm going to say x max goes to 60. It might be 60 years. We'll see. And now I can see the graph. So remember, to find the intersection point, you do second, trace, and then 5, which is intersect. And then since we're only looking at one intersection point, you don't even have to move the cursor over there. You can just kind of hit enter 3 times. And it should put us at 32.819. So I get that t is approximately 32.819 years after 2000. Now, to do it without the calculator, to use algebra, I mean, we'll still have to use the calculator to get a number. You set it up the same way, except for this time we're doing 11.55. We have 6.08. 1.0126 to the t. I don't like rounding, so it's more exact, but you can if you want. To solve algebraically, we need to bring the t down. To bring the t down, we have to divide by the 6.08 first to get it out of there. So that's gone. And then I'm going to natural log both sides, because to bring the t down, you have to natural log both sides. So what happens is I get the natural log of this fraction equals t times the natural log of 1.0126. Then you just divide by this fraction here, or this natural log here. Type all of this is the exact answer. Type all of that into the calculator, and when you do, you get 51.247 years. Okay, so that's how you solve it algebraically. You divide the initial amount out of there first, then you have to natural log both sides to bring the t down in front, and then divide by the natural log of the rate for this one. Okay, so number 2 is similar. According to Kelley Blue Book, the value of a Dodge Stratus that is t years old can be modeled by this given function. Again, note these few things here. That should be your initial amount of how much they paid for the car. Here is the rate. In there, if it's in there, that means it's how much was taken off from 1. So the rate is actually a 16% decrease, because that's how much was taken off of 1 to get 84% left over. So we can do the same thing again. I'll do a calculator, and I'll do the non-calculator way. So 15,000 equals 19,282. Either way, you set it up the same way. You always set up your equation. And there's my equation. So now I'm going to go to the calculator. And on the calculator, you should have 15,000 in your y1, and then the 19,282 times 0.84 to the x in your y2. So pause the screen, get that in there before we move on. Now, if you graph this right now, we're not going to see much, because if you think about it, well, you might see the end of it. But think about how much this car is worth at the beginning. The initial amount is like 19,000. So we're going to have to change our y max, which is the highest point, to about 20,000. So now if I graph that and graph it up to 20,000, we can see where the intersection point is. So I could hit second trace 5 again, enter, 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 and we get the 1.440 for t. So after only 1.44 years, the car will be depreciated from 19,282 all the way down to 15,000. So now we can do algebra again. 2,000 is equal to the same model. I can divide by the number out in front, so that's gone. And then I can natural log both sides. So now because of that, the t can come in front. So I have the natural log of this fraction over 19,282 equals t times the natural log of 0.84. Then you divide by natural log of 0.84. And you are left with this amount here. And when you type that in the calculator, you get a t of approximately 12.997 years old. So it'll be about 12, it'll take 12, almost 13 years to get down to 2,000 for its value. Okay, so now we're going to go on and do exponential. Now, this is an exponential function where e is the exponential function, I should say. AO is the initial amount, so right away, if I'm reading, we have a substance that's radioactive. We have 100 grams for that, so this is A sub 0 here. It says, what is the decay rate? Well, the rate is up here. Remember, it's e to the kt, and k is the decay rate. So we would say it is 0.0244, or if we make that a percentage, it's 2.44% decay. Okay. Then it says how much is left after 9 days. Well, that we're actually given a t value, so we can just plug in, well, at 9, we're starting with 100, we have e to the negative 0.0244 times 9. And when you type that into the calculator, you get about 80.284 grams. Okay. Now, these two problems you can do with the calculator. Let's set it up. We want to know now how long it'll take to get 70, starting at 100. But I find that these go fast with algebra, so I'm going to just do the algebra way. But again, you can do y1, y2, change your window, find the intersection point. First thing we have to do to solve it algebraically is divide the 100. And 70 over 100 is 0.7. Now we natural log, and when we do these problems, it's actually kind of nice because when you natural log base e, they go away and you're just left with this number. So then the final step is, it's this number t equals natural log of 0.7, divide by negative 0.0244. Divide by negative 0.0244. So this is our answer right here. So t is approximately 14.618 days. Since we're in days. What is the half-life? Well, that means how long does it take for it to go down to half of its original starting weight? So we're going, or mass, I should say, but so that would be 50 because 100 is the initial, so half of that would be 50. And then we do the same thing we just did for part C. Divide by 100, so we get 0.5 is equal to this. Then we natural log both sides, and the whole reason we do that is so that the e can go away with that, because it's log base e of e. And then we divide by this same rate that we had k value. So this is the answer, whatever that is. So t is approximately 28.408. Okay, and again, that is days. So algebra works better when it's an e base, because when you natural log both sides, the e goes away. All right, last problem. We have a population of a Midwestern city follows the exponential law. Again, that is A equals A sub 0 e to the kt. Now, this is one where we do not know the decay rate. That's what we're going to have to find. The population decreased from 900,000 to 800,000 when t equals, well, it says from 2013 to 15. I'm going to say that t equals 0 for 2013 and t equals 2 for 2015, because that would be 2 years later. We know that our initial amount, this is our initial amount, and then we know we have t equals 2 and when our a value is 800,000. So I can set up to find k and say, well, I know I have 800,000 and I know it started with 900,000, and that happens after 2 years. Divide, you get 8/9 equals e to the 2k. Natural log both sides, those go away. Divide by the 2. So k is approximately negative 0.05889. Now that we have k, we can find the rest of the problem. There's no way to answer the problem without the k value. So now I have an equation that is just this. And now it's saying, tell me how many people there are in 2021. Well, since I made 2013 0, 2021 would be equal to 8 for t. So I plug that in. And it's times 8. And then you get that it's approximately 561,872 people. Okay, so again, it's all the same stuff. It's make sure you set it up correctly, and then to solve algebraically, you divide by the number out in front, the initial amount first, and then use natural logs to bring the exponents down, and then keep working until you get it. Good job.